my YouTube channel. So we will be continuing discussing the top interview and free series of questions on Leetcode. And our today's question is from binary tree traversal, and the question is flatten binary tree to linked list. So let's go to this question and see what it states. So this question states that flatten binary tree to linked list. Given the root of a binary tree, flatten the tree into a linked list. The linked list should use the same TreeNode class where the right child pointer points to the next node in the list and the left child pointer is always null. The linked list should be in the same order as pre-order traversal of the binary tree. So example number 1 is given as this: 1 2 3 4 5 6. So it should have a pre-order traversal. So pre-order means first value will come, then left subtree, then right subtree. First value, then left subtree, so value, then left 3, then 4 will come, then 5, and then 6. So this is the problem given to us, and number of nodes in the tree is in the range 0 to 2000, and the node dot value varies from -100 to 100, and we have to flatten this tree in O1 extra space. So one key observation here is that in order to solve this question, we would be using stack. And suppose we are at this current node, we will start from the root, and we would put this right node into the stack, and then what we'll do is for this node, we will replace this right node with this left node, and we will set its left node as null, and then we will like move on to the right node. So then we'll come to 2. Again we will do the same thing for 2. We will push this 4 into the stack, and we will make this 3 as the right child of 2, and left child of 2 would be set as null, and then we'll move to the right child of 2. So then we'll move to 3. So 3 like it doesn't contain any right child, and so we don't need to push anything into stack, and now its left child is also null, so we need to pop out of the stack. So this 4 will be popped out of the stack, and then we'll set this 4 as the right child of 3, and left child would always be set to null. So then we will move from 3 to the right child of 3. So we'll come on to 4. For 4 also like right child is empty, so we don't need to push anything, and for 4 left child is also empty, so we will pop out of the stack. So 5 will come out, and we will make this 5 as the right child of 4, and left child would be set as null. So then we'll move to the right child of 4, so we'll move on to the 5, and now here we will push this 6 into our stack, and we will see like left child is null. So now we'll pop out of the stack, so 6 will be popped out, and then it will be set to the right child of 5, and left child will be set as null, and then we'll move to the right side of 5. So we'll come to 6, and then we will check like right child is null, so we don't need to push anything into the stack, and left child is null. So in this case we need to take out the topmost child from the stack, but currently the stack is empty, so we can come out of the function. So in this way we'll get 1 2 3 4 5 6. So this is the crisp explanation, and let's go to the code and see how we are going to implement it. So this is the function which we have to implement, flatten, and we are given TreeNode star root. First of all, we will check if root is equal to null, then we'll return, and then we will define this stack, and we will pass this root and st into our helper function. Then inside this helper function, we are checking if root of right is present, then we'll insert it into the stack, and then we'll check if root of left is present, then we will set this root of right as root of left, and then we'll set root of left as null. Otherwise, if root of left is null, then we'll check if stack is empty, then we'll return out of the function. Otherwise, we will take out the top element from the stack, and then we'll set it as the right child of our current root, and then we'll check if root of right exists, then we'll move on to the right side, and we'll use the recursion. So this is the code explanation, and this is working fine in O of 1 space. Let's try to run it and see whether it will work. So yeah, this is getting accepted here. Let's try to submit it as well. So yeah, this has got accepted. So this solution is working fine. I will attach this code solution in the comment section of the video, and I will also attach this problem link and problem description in the description of the video. So I hope you have understood the explanation to this question. So like this video and subscribe to my channel for more such top into 150 series of questions on Leetcode.